we discuss few problems on welding. Question number 13. It is in 2002 1 mark question. GATE 2002 1 mark question. Which of the following are the welding process does not use consumable electrode? Options are A. Gas metal arc welding, B. Gas tungsten arc welding, C. Submerged arc welding, D. None. So this same question repeated in 2012 also. Same question. So which of the following welding process does not use consumable electrode? As we have discussed in theory that in TIG or gas tungsten arc welding, non-consumable electrode is used. So answer is B. If you look at the option, gas metal arc welding is that is we use consumable electrode. Submerged arc welding we use consumable electrode. Only in case of TIG or gas tungsten arc welding, wherever you find T means tungsten electrode, which is non-consumable. Next question. The temperature of a carburizing flame in gas welding is dash that of neutral or an oxidizing flame. It is GATE 2002 1 more question. Question number 14 in GATE material ME 2002. The temperature of carburizing flame in gas welding is dash that of neutral or oxidizing flame. The temperature of carburizing flame in gas welding is dash that of a neutral or an oxidizing flame. If you remember the concept of oxyacetylene welding, where we have discussed three types of flames: one is oxidizing flame, one is reducing flame, another one is neutral flame. In oxidizing flame we send more amount of oxygen from cylinder. In neutral flame we send equal amount of 1 unit of oxygen from cylinder, and in reducing flame we send less than 1 unit of oxygen from cylinder. So in oxidizing flame and neutral flame, the temperature, maximum temperature developed is more than the reducing flame. Carburizing flame is also called as reducing flame. So option C has given is A is lower than, B is equal to, C is higher than, D unrelated to. So equal to is not all possible. All three methods, because we are sending different contents of composition of oxygen, so definitely temperature varies. So it may be higher or lower. So carburizing flame, more amount of less amount of oxygen we are sending from cylinder, so it need more time to get into maximum temperature. So the temperature is lower than that of normal and neutral and oxidizing temperature. Answer is A. In GATE material they have given B, which is wrong. Please correct it. Next, question number 15. It is also one more question, ME 2001. Two plates of same metal having equal thickness are to be butt welded with electric arc. When the plate thickness changes, the welding is achieved by. It is pressure welding or resistance welding. So if the plate's thickness is same, then if you are sending current electricity in same electricity, so only whenever the plate thickness changes or material changes, then you have to change the electrodes composition, electrode shape. then only it will. Two plates of same material having equal thickness are to be butt welded with electric arc. So when the plate thickness increases, so the welding is achieved by option A is adjusting current, and option B is adjusting the duration of current, option C is changing the electrode size, option D is changing electrode coating. So coating doesn't make sense, it doesn't affect if the thickness changes. So out of the remaining three, changing time, adjusting the duration of current. So welding you have to do simultaneously, like anode you have to send more time current. It's not like that. So option B is wrong. So option A or B, option A or C. So adjusting the current, current actually it's generally in electric arc welding. Instead of changing current, we can change the electrode size, which is much better, especially if you change the diameter, it will automatically decrease the resistance or increase the resistance, whatever you need to do, and then the current change, the passage of current varies. So in that way you can complete that one. So 15th answer is C. For welding two different thickness plates or for welding two different materials, we use resistance welding or pressure welding. In that case, we change the electrode size to compensate the differentiation in the thickness or difference in the materials. That is about question 15. One mark question in 2001. Question number 16. ME 2001. He has given again on resistance spot welding 2 marks question. Resistance spot welding is performed on two plates of 1 mm thickness and 6 mm diameter electrode with 6 mm diameter electrode using 15,000 ampere current for a time duration of 0.25 seconds. Assuming the interface resistance be 10 power minus 4 ohm, the heat generated to form the weld is. Resistance welding, heat generated, you need to calculate heat generated equal to I square RT, simple formula. Power equal to VI. If you look at the options units, he has given watts second, so you need to take I square RT, time also consideration. Given data, he has given thickness of the two plates is 1.5 mm, 1.5 mm with 6 mm diameter electrode, diameter of the electrode. The current passing through the electrode, I, current equal to I equal to 15,000 amperes. The current passed for a time period, time t equal to 0.25 seconds. Resistance R equal to 0.0001 ohms. Substitute in the formula heat generated. Now you will get heat generated Q equal to Q generated equal to I square 15,000 resistance 10 power minus 4 into time. You will get answer 5625 watts second. Simple. 2 marks question you can solve in just half a minute. Next question is in oxyacetylene gas welding, the temperature of the inner cone flame is around. options they have given, we know that in oxyacetylene welding there are three types of flames. So out of the three types, he has not mentioned. Question number 11, 1 mark question, GATE 2003. In oxyacetylene gas welding, the temperature of the inner cone of the flame is around. Temperature of the inner cone of the flame. A is 3500 degrees centigrade, B is 3200 degrees centigrade, C is 2900 degrees centigrade, D is 2550 degrees centigrade. As we have discussed, in oxyacetylene welding there are three types of flames which we can use. One is oxidizing flame, another one is reducing flame, another one is neutral flame. In oxidizing flame, higher temperature will get generated, it's near about 3400. In neutral flame it is about 3200. In reducing flame it is about 3100. So all the temperatures are above 3100 and less than 3400. So which of the options, you can eliminate C and D options which are less than 3000. So the answer may be either A or B. So he has not mentioned which type of flame we need to consider. So if he has not mentioned, means we need to consider neutral flame. So neutral flame, 3200 is the nearest answer. So answer is B. Next question. Next question number 9. This is 2 marks question, ME 2004. Here the problem is 1 mm thick steel sheets are to be spot welded at a current of 5000 amperes, assuming effective resistance to be 200 micro ohms and current flow time of 0.2 seconds. Heat generated during the processes. It's again direct substitution question. Heat generated equal to I square RT. The 2 mm thickness to 1 mm thick steel sheets. Thickness of the steel sheet. Thickness of steel sheet equal to 1 mm. Current passing through the electrode. Current I equal to 5000 amperes. Effective resistance, which is nothing but resistance. Effective resistance is R equal to 200 micro ohm, that means 200 10 power minus 6 ohm. Current flow time 0.2 second. Heat generated equal to I square RT, that is equal to I is 5000 into R is 200 into 10 power minus 6, T is 0.2. Substitute, you will get answer 1000 joules. Question number 7. ME 2005, 1 mark question. So the question they asked is the strength of brazed joint. In braze welding, the strength of brazed joint depends on, they have given options: decrease with increase in the gap between the two joining surfaces, increase with increase in the gap between two joining surfaces, decrease up to certain gap between the two joining surfaces beyond which it increases, increase up to certain gap between the two joining surfaces beyond which it decreases. So to understand this, we will draw two. Suppose I am joining to this place by using brazed welding, brazed welding or brazing. So if you look at the first option, the strength of the joint, strength of this joint increase Strength of this, the first option A is strength of the brazed joint decrease with increase in the gap between the two joining surfaces. Initially, if there is no gap, then you can't weld. So the strength is 0. As you increase the gap, the strength goes on increasing, and after some time, if the gap is huge, again the strength goes on decreasing. The strength of the any welding between the plates, the gap is initially it increases, after certain point it will be maximum strength attains, then after that it will decrease, whether it may be brazed welding or any other welding. So similar to here, first option is wrong. Second option, increase with increase in gap between two joining surfaces, it is also wrong, because if you increase the gap too much, then the joint will be weak actually, obviously. C, decrease up to certain gap between two joining surfaces beyond which it increases, it is wrong. So option D is correct. Why means increase up to certain gap. Obviously, initially if there is no gap between two plates, so welding doesn't make sense. And if you increase slightly gap, which allows the weld bead into the gap such that it will attach the two plates, so the gap has to be optimum such that the joint has maximum strength. So to get the optimum, it will take some distance. So increase the strength of the brazed joint increases up to certain gap, and if the gap is too much, if it goes on increasing, then obviously the strength of the any welding is goes on decrease, it will decrease. So D is the answer. Next question is question number 6, 2 marks question, ME 2006. In an arc welding process, the voltage and current he has given. So voltage V equal to 25 volts, current equal to I 300 amperes. The arc heat transfer efficiency is 0.85, welding speed is 8 mm per second. So heat transfer efficiency, here you need to know what is heat transfer efficiency, equal to 0.85. Welding speed equal to 8 mm per second. The heat input joules per mm in joules per mm is dash, that is a question. So he is asking how much heat is input. So to solve this equation, he has given voltage equal to 25 volts, current equal to 300 amperes. So if you remember the formula, then you can't solve this problem. So you have to remember the logic of how welding efficiency, all these formulas. So first of all, we find the how much heat is generated. Heat generated equal to Q generated. So if you send a current of 300 ampere at a voltage of 25, it will generate current I square RT. So here Q equal to VI, also you can write. This is watt second, this is watts. So if you consider time, then it is watt second. If you doesn't consider time, then it is watts. Heat generated Q equal to I square RT, which is watt second, is nothing but joules or joules. Energy is represented in joules also. So power, this is another formula, sorry, this one is it correct. Power equal to VI is equal to the joules per second, that means watts. VI is in watts. But we need heat generated in terms of joules per mm, because we need heat input in joules per mm, so we convert heat generated in joules per mm. Joules per mm. So to convert that, what we have to do is, basically it has given velocity, so power by velocity equal to Vi by velocity. So now watts means watts by mm per second. Watts is equal to joules per second, which is equal to joules per second by mm per second. Second will go, so joules per mm. This is how to get heat generated in joules per mm. So he has given heat transfer efficiency. Heat transfer efficiency equal to, that means how much amount I am generating, this much energy I am sending power, and because of volt it generates 100 watts of power, but entire power is not converting into heat in the weld, going to the weld. So the input to the weld is less because there is a loss to atmosphere and other losses, spatter losses. So to accommodate that, heat transfer is there. So heat transfer is heat input to weld bead, heat input to weld bead, that means heat input to weld, divided by heat generated due to current and voltage. So even though, for example, I am generating 100 watts energy or power, entire amount is not transferring into the weld bead, so only few amount. That's why we are using efficiency. He has given 0.85 is 85% efficiency. Heat input we need to calculate. So to get heat generated in joules per mm, Vi by velocity. So then you will get heat input equal to 0.85 into Vi divided by velocity. It's equal to 0.85 into V is 25 300 current, divided by velocity is 8 mm per second. So on substitution you will get answer 797 joules per mm. See, actually if you know the fundamentals of the units and measurements which you may have studied in +2, so then you can solve this problem easily. You don't need to remember any formula in welding, only you need to have idea of heat input, how you have to calculate heat generated and what is efficiency here. Basic fundamentals. Don't remember formula in welding especially. You can remember formula for any other material and other chapters, but for welding you can solve problems easily without remembering any formula. If you remember formula, you will definitely get confused because the problem they won't ask directly. 2 marks question, which is very easy question they will ask. Otherwise if you remember formula it will become tough. So next question. Question number 5, which is again 2 marks question, ME 2007. I think this is if you look at the question, 99% of the people won't even attempt. So the question is near about 10 lines, but if you know the concept you can solve this question. So two metallic sheets each of 2 mm thickness are welded in lap joint configuration by resistance spot welding at a welding current of 10 kiloamperes and welding time of 10 milliseconds. A spherical fusion zone extending up to the full thickness of each sheet is formed. The properties of metallic sheets are given as ambient temperature 293 Kelvin, melting temperature 1793 Kelvin, density of the molten metal is 7000 kg per meter cube, latent heat of fusion is 300 kilojoule per kg, specific heat is 800 joule per kg Kelvin. Assume contact resistance along sheet interface is 500 micro ohm and along electrode sheet interface is 0. No conductive heat loss through the bulk sheet materials, and another assumption is the complete weld fusion zone is at melting temperature. Find the melting efficiency of the process. By the time I came to the last line, I forgot the first line what he has given. This much huge problem they have given for 2 marks. Why they give this type of big problems is, so these type of problems you need to solve at the once you complete entire question paper, and that too these problems will differentiate between the average student and best student. If you want to get good rank, you need to try to attempt this problem, and by looking at the problem you will get to know that it will take some time, maybe 2 minutes definitely, but if you are sure then only attempt it, otherwise don't attempt this because it kills your time in gate. But as for our new format, time management is not that much important, so because you will get enough time, 3 hours 180 minutes for only just 60 seconds, 60 questions, 60 or 65 questions. Out of them you can solve most of the questions in less than 30 seconds, so you will get minimum 2 minutes for each question. So I think you can solve easily 3 minutes you will get in. So don't leave any question until unless it is irrelevant to the concepts which you have studied. If you are not at all aware of the concept, just leave it, then you can try it later. So just I will write it down the what he has given, then you can solve your own. Simple question only, but only thing is he has given huge problem. 2 metallic sheets each of 2 mm thickness are welded in lap joint. So before going this, you should know what is lap joint. In welding, in design of welding the joints, you may have studied lap joint. This is lap joint. Butt joint means plates are side by side. Lap joint means plates are on top of each other. So each are 2 mm thickness. The thickness of plates is 2 mm. Next is current, welding current. I equal to 10 into 10 power 3 amperes. Welding time 10 millisecond, 10 in 10 power minus 3 second. A spherical fusion zone extending up to the full thickness of each sheet is formed. So he is telling that the zone here is spherical zone. It is extending to the 2 mm thickness, means radius is 2. Indirectly he is saying it is the spot welding. This is spot welding, right, at a particular point. So this spot is shape of sphere and the radius is thickness of the sheets. So that means 2 mm thickness. Next, he has given the properties of the metallic. So we need to note down the properties. Spherical spot of radius equal to 2 mm. Ambient temperature 293 Kelvin. Melting temperature 1793 Kelvin. Density 7000 kg per meter cube. Latent heat of fusion 300 kilojoule per kg. Specific heat. Melting efficiency. So we need to calculate what is melting efficiency. Melting efficiency equal to heat required to melt divided by heat generated. Heat required to melt molten metal pieces divided by heat generated. So heat generated, we know heat generated equal to I square RT. Substitute this, I will just give the notations. I the time we know, and what is resistance, surface sheet resistance. Okay, sorry. Resistance, given resistance is 500 micro ohm. So substitute I, R and T, then you will get Q generated equal to 500 joules. Next, heat required to melt the metal piece before joining equal to MCP delta T and ML. Heat required equal to, you have to convert MCP specific heat into delta T. It is, first you need to convert from room temperature to melting point temperature, then from in melting point temperature you have to convert from solid to liquid, so change of state. So M is common, Cp delta T plus L. M equal to density into volume. Cp is specific heat, he has given as 800 joules. Delta T is temperature difference, 1793 minus 293 plus latent heat of fusion is 300 kilojoules. So density also he has given, and volume equal to 4 by 3 volume of sphere. He has mentioned the spherical space of that butt. So 4 by 3 pi r cube. So radius is 2 mm. Substitute radius equal to 2 mm. You will get volume. Then after substituting, heat required equal to, the value is, so heat required is approximately near about 350 joules if you after substituting all values in the above formula, and melting efficiency equal to the heat required by heat generated, 350 by 500 into 100 percentage to get a percentage. So you will get 70.35 is the melting efficiency. So simple question only. If you know the concept, you can do in less than 2 minutes. Next question. Question number 4. Get 2007 and as well as 2012. Similar question they asked in 2012 for 2 marks. So a direct current welding machine with a linear power characteristics on open circuit voltage 80 and short circuit voltage of short circuit current of 800 ampere. Open circuit voltage equal to V0 equal to 80 volts. Short circuit current IS equal to 800 amperes. During the welding with machine, the measured arc current is 500 amperes corresponding to an arc length of 5 mm and measured 460 corresponding to an arc length of 7 mm. So corresponding to arc length characteristics, arc current I equal to 500 amperes for L. L is the length between the electrode and the workpiece, 5 mm, and 460 for 7 mm. He has mentioned the voltage and length, arc length characteristics are in linear characteristics. V equal to A plus BL is one equation, and we know V equal to V naught minus I by IS into V naught. So substitute, we know that V naught, we know short circuit current he has given. V voltage we need to calculate. So first V equal to A plus B into 5. So from that equate that equation to same as equal to from 1 and 2. V naught he has given 80 minus I has given as 500 by 800 into V naught is 80. So A plus 5B equal to 80 tens or 30. Similarly, substituting A plus 7B equal to 80 minus 460 divided by 800 into 80. Here you have to 80 minus 46 is A plus 7B equal to 34. Simplifying both equations, equation 3 and equation 4. From equation 3 and 4 subtract, so 2B equal to 4, B equal to 2, substitute B equal to 2 there, then A equal to 20. So finally equation is V equal to 20 plus 2L. So option is A. So answer is A. So this is a question which they asked again in 2012, GATE 2012, 2 marks question. If you solve this type of questions, there is standard formula only, there is nothing twist in this problem. If you simplify this, practice this type of problems a lot such that you can save time and you can eliminate mistakes. So next question. In an two pipes of inner diameter 100 mm and outer diameter 110 mm, each are joined by flash butt welding using 30 volts power supply. At the interface, 1 mm of material melts from each pipe, which has a resistance of 42.4 ohm. If the unit melt energy is 64.4 megajoules per meter cube, then the time required for welding is. Question number 1, GATE 2010. So one of the important, almost they give question only in resistance welding. So it is a pipe, this is a cylindrical pipe A, pipe B. So both are butt welding, flash butt welding. Butt welding means joining side by side. So butt welding. So the area where they joined is 1 mm from each side for welding. The melting area is 1 mm from each side of from each pipe. So to get 1 mm, how much heat is required to melt that one? So this is 1 mm from each pipe, and he has given inner diameter and outer diameter of the pipe, and he also mentioned the current, how much he is applying. So he is asking time required to send the current, time required for welding. So given data, two pipes of inner diameter 100 mm, so inner diameter 100 mm, outer diameter 110 mm. So inner diameter 100 mm, outer diameter 110 mm. So thickness of the pipe is 5 mm. Voltage supplied 30 volts. Units are more important. The interface is 1 mm melts from each pipe. Here this is 2 mm total, because 1 mm from each. So 2 mm 1. So thickness is 2 mm. Resistance or 42.4 ohm. Unit melt energy 64.4 megajoules per meter cube. Then time required for welding dash. So if you, after getting the data, if you think of formula, then you can't solve this. So only thing is what he has given, unit melt energy required to melt, he has given, right? So in terms of per meter cube. So first of all, calculate energy required to melt the volume of the joint. So volume of the weld joint equal to area into thickness. Area is how much? Pi by 4 d outer square minus d inner square into thickness is 2. This is the volume of the material. Substitute the values, and then volume you will get is equal to, after substituting all the values, 3298 into 10 power minus 9 mm cube. So that is the volume of the joint weld. Next, energy required to melt, heat required for melting, 54.4 into volume, 64.4 into 10 power 6 megajoules. So that's why 3298 into 10 power minus 9. Then you will get value is, heat required for welding is 212.4 joules. mm cube will get cancelled, you will get joules. So heat required how much. He has not given any mentioned any efficiency. So heat generated is equal 100% efficient, you can check. So now it is equal to heat generated. Heat generated equal to I square RT. T is time. I square RT time. Time actually has given us how much. So we need to calculate time. Sorry. This is equal to heat required, because assuming 100% efficiency. Time required equal to 212.4 divided by I square R. If you simplify this, you will get the value 10 seconds. So answer is C. So in almost all welding problems, you have to be careful in units. Don't need to remember any formula. Only thing is you need to remember is heat generation. And question number 2 in GATE material, academy material. Question number 2, GATE 2008, 2 marks question. Welding of butt joint. Again butt joint. The welding speed is to be selected such that the highest cooling rate is achieved. Okay. Melting efficiency and heat transfer efficiency are. He has given melting efficiency. Melting efficiency equal to 0.5. Heat transfer efficiency 0.7. The area of the weld across the section. Area of weld equal to 5 mm square. The unit energy required for melt of the material is 10 joules per mm. Welding power is 2 kilowatts. What is welding speed? We need to calculate welding speed. Welding power is power input, that is energy required to melt. So here energy required, total energy required for melting the weld bead equal to unit energy into volume. Q required 10 into volume joules. So we have only area, we don't have volume. Instead of this you can write 10 into area into velocity, then in terms of watts. Heat required in watts. So we know welding power is, input power is 2 kilowatts. Total energy input, energy required, Q required equal to Q in applied or input, Q generated. The Q required is 10 into area into velocity equal to Q input 2 into 10 cube watts into efficiency, both efficiency, melting efficiency into heat transfer efficiency. Because I am generating 2 kilowatts, but entire amount is not transferring, going to the welding, so there are a lot losses. That's why heat transfer efficiency I am losing some energy, and even melting, while melting also I am losing some heat. Finally, substituting velocity equal to 2 into 10 cube into 0.5 into 0.7 divided by 10 into area. How much is area? 5. See, after substituting you will get velocity is V equal to, velocity equal to 14 mm per second. Velocity of the welding is 14 mm per second. So after observing these few problems, you will come to know that you just need to remember the concept, don't by heart the formula. Then you can solve any problem.